And we've all heard about the primary benefits of NFV technologies, that's scalability, agility, automation, that to increase time to market for our products and services, but what about the other benefits that have emerged since Mobile World Congress 2015, miniature cloud-based replicas for deploying a steady flow of innovation into a live network can be a challenging concept to wrap your head around. So today in the Dell TI&L studio to give us more insight into what's next for NFV is Daryl Jordan-Smith. He's Worldwide Vice President of ICT at Red Hat. Also on the panel is John Healy. He's General Manager of the SDN Division at Intel. And gentlemen, welcome to the program.
Thank you.
Good to see you, Abe.
Thank you both for being here. You've been on a number of our panels in the past. You've also talked about network functions virtualization, SDN. We've always talked about the benefits of those two technologies. Specifically though about OpenStack as a cloud management platform and beyond scalability, beyond CapEx, reduced CapEx, and automation, what are some new benefits of NFV that we can talk about? Daryl, I'll start with you.
Well, I think you mentioned them earlier in terms of the ability to deliver new applications and services and the agility associated with doing that. But in addition to that, what we're seeing in the marketplace is the focus around containerization potentially of those technologies and the density that you can actually reach to actually get next generation services out there and deployed very quickly.
Anything to add, John, before I move on?
I think some of the applications we're seeing as the first movers in NFV specifically are really showing what becomes possible from a CapEx reduction perspective, but more importantly from an OpEx reduction. Virtual CPE is a great example of that. Reducing the need for the truck roll, the maintenance of in-field equipment at the site, and presenting services to the site, but from the cloud, from the edge of the network.
John, I want to, in light of day one of Mobile World Congress 2016, I want to just go back into a little bit of the history of network virtualization from the discussions around SDN a couple years back, again last year to NFV, and then now the convergence of cloud computing, SDN and NFV and that discussion. Take us back a couple years.
Yeah, I think back over the last several years, maybe even the last decade, we've seen three somewhat independent but very interrelated efforts. Cloud computing, evolving as a way of providing centralized orchestration of resources and the pooling of those resources for applications, to enable applications to be configured and supplied and implemented. SDN very much grew out of the need to abstract control and management from the resource, so you had a central view of your resources and you could configure and manage them programmatically. And then NFV really emerged out of the work with the service provider community and communications and the ETSI definition of a network function virtualization, separating the application or the function from its underlying hardware and dependence on it. And of course all three have really started to blend together now in how it presents a fully programmatic, software controlled, software enabled set of new services for the network, for all domains, whether they're telecoms networks in the traditional sense, enterprise or cloud networks. I think I'd add a fourth dimension that's very prevalent in the MWC 16 is the emergence of 5G and the opportunity that's being presented now as this underlying infrastructure of SDN NFV and cloud-like technologies present an architecture upon which next generation services, particularly for the mobile consumer, whether it's a device or an individual, are really being enabled on top of that platform.
Daryl, if I can, I wanted to get your perspective, your sentiment about how we build, operate, and use the internet now in the midst of network functions virtualization.
From an orchestration perspective, I think that we're seeing a lot of innovation in those areas. We're seeing different groups coming forward with different ideas and different concepts in terms of how to manage the orchestration layer and how to enable those next generation services. In particular, building SLAs around them that they can actually commercialize them, build quality of service around them so they can actually build them, and actually really taking that to the next phase. And I think John just highlighted a couple of examples of where that would be the case.
Do you feel like the Internet of Things is a catalyst for NFV or vice versa, or do they work in tandem?
I think they work in tandem, but as John said, 5G, in terms of what that's actually going to provide the marketplace, the density in which we need to provide the infrastructure that's necessary to support it, really to enable the Internet of Things. So from our perspective, NFV is an enabling platform for 5G and enabling those operators to deliver such services.
John, I wanted to talk about, primarily in this discussion, about miniature cloud-based replica networks into a live network. Can you give us an example of how that works?
So I think a great example actually is IoT. You consider how the very domain-centric services start to emerge for healthcare, for transportation, for security services, et cetera, management of smart cities. Each of those starts to represent a form of miniature cloud, close to the edge of the network, specifically configured around the implementation of a service category for that little micro vertical. All of that requires not just the highly configurable infrastructure against which it can be implemented, but a continuous integration scheme sort of toward a concept of DevOps or development operations, where the service is implemented first with a set of features around it and then incremented over time as the consumption varies, as the requirements from that particular micro segment vary, and that becomes possible in a manner which is streamlined, as opposed to conceive project, implement project, deploy over time. You move into a much more continuous integration cycle where services are turned on, they're adjusted and optimized largely on demand, and that can vary and be different depending on the micro segment that's being served.
Clearly, Daryl, product deployment, service deployment has increased exponentially with the advent of NFV. Can you give us an example, maybe something somewhat similar to John's?
Well, I mean, we were talking a little bit about DevOps there, and I think that a lot of operators, as they get to highly dense NFV-based deployments, using containerized technology as part of that architecture, we're going to be in a situation where people are going to iterate, very much like open source works today. We build on what already exists and we improve on what already exists. So that continuous agility, rather than ripping down a service and then pulling up a new one, will happen in almost real time.
Now we talk about carrier performance, but now we're also talking about service performance, delivering services at a 5.9 or a 6.9 level. In an OpenStack environment, what are the challenges there? And John, I'll start with you.
I think there's a traditional view of what were communication service provider networks, which were carrier grade capable, high availability, very predictable throughputs, and very ill tolerant of redundancy, et cetera. The kind of carrier grade attributes. In a cloud-like implementation, they haven't been the same level of demand or requirement placed on it, simply because of the type of application it's supported. However, if you think about financial services networks, healthcare implementations, there's a lot of the same kinds of expectations in terms of availability and resiliency of the service that we've been known to be more traditional in comms networking or in telecoms. What needs to happen with OpenStack specifically, but orchestration mechanisms in general, is that they continue to evolve toward an orchestration scheme that can serve the needs of each of these different markets and the different usage types, from high availability perspective, from carrier grade ruggedness, from a service implementation, not necessarily on a per device basis, but across the service that's being implemented. Carrier grade in that sense is a little bit of a different beast from what we might have known in the past, but more appropriate to an environment where things are very flexible because they're virtualized and more software programmatic. I also suggest that as we move toward more of the Internet of Things, we're going to see a different scheme of what carrier gradeness and ruggedness means as you start to deploy it down to individual devices in a device-to-device perspective.
Daryl, cloud management platforms like OpenStack, what are the requirements that NFV is placing on that?
Well, I think that NFV itself is evolving to look at orchestration from a service chaining perspective. So we talk about different VNFs delivering different services across the network, chaining those together to deliver more end-to-end, more complex service. We talked just now about DevOps, creating new services and applications in that particular environment. So I think NFV is really going to become the base level infrastructure that enables a lot of that technology to take place.
You talked about containers or containerism earlier. I want to talk about Linux containers, and is this a phenomenon now that we're talking about this as far as cloud computing goes?
Well, I think Google as a company itself deploys in very high dense environments containerized technology. It's how they deliver a lot of their services and deploy that in a very agile manner to their subscribers that utilize their service. I think from a telco perspective, they're going to need to move into that model with more traditional telco-like services. We use CPE as a use case example. There are many more that we see evolving from that space and the utilization of that particular technology.
From Intel's perspective, container or containerism benefits?
I think very similar to what Daryl said. It creates highly dense implementation options and highly it can take tremendous advantage of the underlying platform's abilities, so you can pass those abilities right through to the virtual function that's running on top.
John and Daryl, great to have you both talking about NFV, OpenStack as a cloud management platform as well. I'm sure we'll be talking later in this event and in future events as well, so thanks for your time.
Thank you.
Thanks. And as always, for our continued coverage from the event floor at Mobile World Congress 2016, please go to tianow.org and follow us on Twitter at TIA_now. So long.